Welcome to Math with Mr. J. In this video, I'm going to cover percent error. This is going to be a beginner's guide to percent error. We'll talk about what percent error is, how to calculate percent error, and go through some examples. We will start with 4 kind of introductory examples to help us understand percent error. And then we will move on to 3 more examples where we will calculate percent error. Now basically, percent error is a way for us to see how far off a measurement or estimation is from the actual value, written as a percent. When we take measurements or make estimations, we're not always exactly accurate. So percent error is a way for us to see how accurate a measurement or estimation is relative to or compared to the actual value. Let's jump into our examples, starting with number 1, where we have the owner of a restaurant estimated that 45 customers would come in for lunch. The actual amount of customers was 36. Calculate the error and percent error. Now you'll notice we're calculating error and percent error here. We'll see the difference as we work through this. Now to calculate percent error, which we have the formula right here, we take the measured value or estimated value and subtract the actual value. Then we take the absolute value of that result. So if it's negative, it will turn positive. Then we divide that by the actual value. This will give us a decimal. We then multiply the decimal by 100 to convert it to a percent. So let's set this up for number 1. We have percent error equals the absolute value of the estimated value, that's 45, so 45, minus the actual value, that's 36, divided by the actual value, so again, that's 36, times 100. And now we can work through this. Let's start with the subtraction. So we have 45 minus 36. That gives us 9. So we have the absolute value of 9 divided by 36 times 100. Now before we move on, I want to mention that when we take the measured value or estimated value and subtract the actual value, that gives us the error. And the error is how far away we are from the actual value. So for number 1, the owner's estimate of 45 customers was off by 9 from the actual value of 36 customers. So again, when we take the measured value or estimated value and subtract the actual value, that gives us the error. So for number 1, the error is 9. And that's a positive 9. That positive is important because it tells us that the estimate is over the actual value. It was over by 9. On the other hand, a negative indicates that the estimate was under. And we'll see what that looks like with number 2. So the error for number 1 is 9. And we can even highlight that it's positive by putting a positive sign in front. Again, that shows us that the estimate was over by 9. Now let's continue to work towards the percent error. So let's take the absolute value of 9. That's 9. So we have 9 divided by 36 times 100. Now taking the absolute value of the error gives us the absolute error. That's 9 here. And we have that over the actual value, 36. Now this is a ratio, the ratio of the absolute error to the actual value. In other words, we have the absolute error compared to the actual value. This ratio is called the relative error. Now we need to divide to get this to a decimal. So we have 9 divided by 36. That gives us 0.25, 25 hundredths. Converting that decimal to a percent gives us the percent error. So we're presenting the error as a percentage of the actual value. So we need to multiply that decimal by 100 in order to convert it to a percent. And remember, a quick way to multiply by 100 is to move the decimal twice to the right. So once, twice to the right, and that gives us 25%. So the percent error, 25%. Let's move on to number 2, where the owner now estimates for the dinner crowd. We have the owner estimated that 110 customers would come in for dinner. The actual amount of customers was 125. Calculate the error and percent error. So let's set this up. We have percent error equals the absolute value of the estimated value, that's 110, minus the actual value, that's 125, divided by the actual value, 125, times 100. Now let's work through this. So we will start by subtracting. We have the estimated value, 110, minus the actual value, 125. That gives us negative 15, and that's our error. So we have the absolute value of negative 15 divided by 125 times 100. So this is our error right here. Negative 15. Now that negative tells us that the estimate was under. So the owner's estimate was off by 15, and again, it was under by 15. Let's continue to work towards the percent error. So we need the absolute value of negative 15. That's positive 15. So we're getting rid of the negative sign. And then we divide that by 125, and then multiply by 100. So 15 is the absolute error, and we have that over the actual value of 125. So we have the ratio of the absolute error to the actual value. This is the relative error. Now we need to divide to get this to a decimal. We need to do 15 divided by 125. That gives us 0.12 12 hundredths. And we need to multiply that decimal by 100 in order to convert it to a percent. So let's move the decimal once, twice to the right, and that gives us 12%. And that's our percent error. So 12%. Now looking at numbers 1 and 2, was the owner's estimate more accurate for number 1, lunch, or for number 2, dinner? Well, the error for number 1, the owner was off by 9. His estimate was above the actual value by 9. For number 2, the owner's estimate was off by 15, and the estimate was under the actual value. The easy answer would be to say that the lunch estimate was more accurate because the error was less. We have off by 9 compared to off by 15. But this is actually incorrect. The error doesn't give us enough information. The numbers we are working with and their size matter, and we have different numbers for lunch and dinner. So we have to see how the errors relate, how they compare to the actual values, and that gives us a much better idea of how accurate a measurement or estimate is. For lunch, the percent error was 25%, so the estimate was off the actual value by 25%. And then for dinner, the percent error was 12%, so the estimate was off the actual value by 12%. So that tells us that the owner's estimate for dinner was quite a bit more accurate than the estimate for lunch. And percent error gives us the information we need to make that determination. Now let's take a look at two more examples to help us better understand percent error. Here are two more examples of percent error. Let's take a look at number 3, where we have an estimated value of 7 and then an actual value of 28. Now I calculated the error and percent error for both of these examples. We're going to compare these examples in order to see how percent error can be more helpful than just looking at the error itself. So we're building on our understanding from numbers 1 and 2. Now the estimate for number 3 was off by 21. Specifically, the error was negative 21. So the estimate was under the actual value. This gives us a percent error of 75%. So really, this estimate wasn't very close at all. Keep in mind, the higher the percent error, the lower the accuracy. The lower the percent error, the higher the accuracy. You want a percent error to be as close to 0% as possible. A 0% error means that the measurement or estimate was exact. It was the same as the actual value. So 75% here is pretty high. That's pretty far off. Now looking at number 4, the estimated value is 1,010,000. The actual value is 1 million. That means the estimate was off by 10,000. Specifically, the error was positive 10,000, which tells us the estimate was higher than the actual value. Now, an error of 10,000 may sound like a lot, but because of the numbers we are working with here and their size, we have a percent error here of only 1%. That's a close estimate, only 1% off the actual value. Now, if we just compared the errors between numbers 3 and 4, so off by 21 compared to off by 10,000, we would think that number 3 was a better estimate by a lot. But looking at the percent errors, number 4 is actually a much better estimate than number 3. Let's move on to numbers 5, 6, and 7, where we will calculate the percent error from a given situation. Taking a look at number 5, we have a student measures the mass of an object as 57 grams. The actual mass is 60 grams. Calculate the percent error. So let's set this up off to the side here. We have percent error equals, and now we need to take the absolute value of the measured value minus the actual value. The measured value is 57. So 57 minus the actual value, which is 60. And we need to divide that by the actual value, which again is 60. And then we multiply by 100. And now we can work through this, starting with the subtraction. So we have 57 minus 60. That gives us negative 3. And we are dividing that by 60 and multiplying by 100. Now we take the absolute value of negative 3, which is 3, positive 3. So 3 divided by 60 times 100. And now we divide. We do 3 divided by 60. That gives us 0.05, 5 hundredths. And we need to multiply that decimal by 100 in order to convert it to a percent. And remember, a quick way to multiply by 100 is to move the decimal twice to the right. So once, twice. That gives us 5%. So the percent error for this example is 5%. That means that the student's measurement of 57 grams was off of the actual mass of 60 grams by 5%. Let's move on to number 6. For number 6, we have an event planner estimates that there will be 325 guests at an event. 364 guests end up attending the event. Calculate the percent error. Round to the nearest percent. So let's set this up. We have percent error equals the absolute value of the estimated value. That's 325 minus the actual value. That's 364 divided by the actual value. So 364 times 100. Now we can work through this, starting with the subtraction. So 325 minus 364. That gives us negative 39 divided by 364 times 100. Now we need the absolute value of negative 39. That's 39, positive 39. And now we can divide. So we have 39 divided by 364. That gives us 0.107, and that decimal continues on. So I'm going to stop there because we're going to round to the nearest percent. And we need to multiply that decimal by 100. So let's multiply it by 100 in order to convert it to a percent. So we need to move the decimal once, twice to the right. That gives us 10.7, and again, that decimal continues on. So we're going to round to the nearest percent here. And when we round to the nearest percent, we round to the ones place. We have a 0 in the ones place with a 7 to the right in the tenths. So this rounds to 11%. So our percent error is approximately, and I'm using the approximately symbol here since we rounded, 11%. So that means that the event planner's estimate of 325 guests was off by approximately 11% from the actual amount of guests, 364. Let's move on to number 7. Lastly, for number 7, we have you measure the length of an object and get a measurement of 10.9 centimeters. The actual length of the object is 10.7 centimeters. Calculate your percent error. Round to the nearest percent. So let's come over here and set this up. We have percent error equals, and now we need the absolute value of the measured value minus the actual value. The measured value is 10 and 9/10 minus the actual value of 10 and 7/10 divided by the actual value, 10 and 7/10 times 100. And now we can work through this, starting with the subtraction. So we have 10 and 9/10 minus 10 and 7/10. That gives us 0.2, 2/10. And we need to divide that by the actual value times 100. Now we need the absolute value of 2/10, which is just 2/10. Divided by the actual value times 100. And now we need to divide. So we need to do 2/10 divided by 10 and 7/10. So 0.2 divided by 10.7. That gives us 0.018, and that decimal continues on. So I'm going to stop there because we're going to round to the nearest percent. And we need to multiply by 100 here. So now let's multiply that decimal by 100 in order to convert it to a percent. And we do that by moving the decimal once, twice to the right. That gives us 1.8, and that decimal continues on. So let's round to the nearest percent. And when we round to the nearest percent, we round to the ones place. We have a 1 in the ones place with an 8 to the right in the tenths. So this rounds to 2%. Our percent error here is approximately 2%. And I'm using the approximately symbol there since we rounded. That means that the measurement of 10.9 centimeters was off the actual length of 10.7 centimeters by about 2%. So there you have it. There's a beginner's guide to percent error. A little bit about percent error and also how to calculate percent error. I hope that helped. Thanks so much for watching. Until next time, peace.